The strangest part of winning is how fast it disappears. 6 months of training, one finish line, and 5 minutes later, your brain is already asking, is that it? You cross the line, and for 1 second, it feels exactly like you thought it would. Then the crowd sounds normal again. The chute looks normal. Nothing in the world changed as much as the chase promised it would. That letdown is not a personality flaw. It's a piece of neural wiring doing exactly what it evolved to do. One built to reward the chase, not the finish line. The exact same structure that made the finish line feel so good is also the reason it didn't last. It's called the ventral tegmental area, and its job is to release dopamine, the molecule everyone already thinks of as the reward chemical. In the early 1990s, a researcher named Wolfram Schultz trained monkeys to expect a squirt of juice every time a light turned on. At first, the dopamine neurons fired when the juice actually arrived. That part matches what everyone assumes. But once the animals learned the pattern, the neurons stopped firing for the juice. They fired for the light instead. That's the moment the reward became predictable. Schultz called this a reward prediction error. Dopamine isn't measuring how good something feels when it happens. It's measuring the gap between what you expected and what you got. Which is bad news if you'd been picturing this exact finish line for 6 months. When Schultz turned the light on and then withheld the juice, the neurons didn't just go quiet. They dropped below their normal resting rate, the closest thing a neuron has to disappointment. And this isn't old data sitting in a filing cabinet. In early 2024, a researcher named Philip Grill scanned living human brains in real time, watching dopamine actually release in the striatum, moment to moment, as people's expectations got proven right or wrong. Same signal, same species you're sitting in right now. You'd been picturing this exact finish line daily for 6 months. By the time you actually crossed it, your brain had already run this exact reward hundreds of times in advance. The celebration wasn't withheld from you today. It already happened, in installments, every time you let yourself imagine crossing this exact line. That's the anticipation half of the story. The other half is what happens on the receiving end, and it explains something stranger: why the same achievement chased twice pays out less each time. Dopamine only does anything once it docks into a receptor on the neuron next door. One of the main ones is called D2. Here's the actual mystery. Out of millions of receptors crowding that membrane, how does the cell find and shut down exactly the right one without breaking any of its neighbors? The answer starts with an enzyme that does one job. It patrols the surface, and it only reacts to a receptor that's actively mid-signal. Dopamine locked in, doing its work right now. When it finds one, it doesn't break anything. It marks it, stamps it chemically 8 times in a spot no untouched receptor has. That stamp is the whole trick. A second protein has been drifting past millions of unmarked receptors, ignoring every one of them. The instant it meets a marked one, it locks on like it's been waiting its entire existence for exactly this signal. It doesn't let go. It grabs a length of a third protein, the same rigging the cell uses to haul things off its own surface, and pulls the marked receptor down and out. Gone. Off the membrane completely. Do that once, and the receptor gets recycled back to the surface good as new. Nothing lost. But do it enough times, fast enough, and the cell starts pulling receptors out faster than it can put them back. That's the entire mechanism. Not one dramatic shutdown. The same precise little heist, run over and over, faster than the cell can keep up. The enzyme is called GRK2. The one that locks on is beta-arrestin. The rigging is clathrin. You don't need to remember any of those names. You need to remember what they just did. Built a security system precise enough to eject one overworked receptor out of millions and leave every neighbor untouched. Researchers have measured this mechanism directly in people with substance dependence and in chronic overeating, both far more repetitive and extreme than a single marathon or promotion. In late 2025, a researcher named Michael Crickmore at Boston Children's Hospital found the same mechanism somewhere nobody was looking for it: fruit flies. Dopamine through the D2 receptor is what makes a male fly keep trying to mate. But the more times he tries, the more those receptors desensitize until he simply gives up and wanders off. It was the first time this receptor mechanism, long associated only with addiction, was shown to have a natural job. It's what produces ordinary boredom, fatigue, and declining interest in something you've done too many times. Nobody has scanned a person mid-achievement to check their D2 receptors. That study doesn't exist yet. But an addicted brain, an overweight patient's brain, and a fruit fly's brain all hit the exact same wall when the exact same reward repeats. There's no known reason yours would be the exception. So here's what that predicts. This is the microscopic version of standing at that finish line. The same door, closing a little more every single time you've stood there before. With fewer doors open, that same size dopamine surge would produce a smaller signal than it used to, which would explain something specific, why the second win never quite lands like the first one did. Not because you stopped caring, because the door it has to walk through would be smaller. To register the same size feeling, the brain wouldn't need you to want less. It would need you to chase something bigger next time. There's a place this exact pattern got dramatized almost perfectly, without ever mentioning a single receptor. In one recent workplace drama, employees get their memories surgically split in half. One version of them exists only inside the office, with zero idea what their outside life is even like. To keep that office version motivated, the company doesn't pay them more. It throws them a waffle party. A literal party for waffles. Watch that scene cold, with no context, and it looks unhinged. Grown adults, overjoyed, nearly in tears over breakfast food. But you've done the exact same thing. Maybe not for a waffle, for a Slack emoji, a 5-star review, a little number going up. The show just filmed the process at the wrong speed. What normally takes you years, one bigger house, one bigger win, one bigger anything, to feel that same spark, happens to these people in a single afternoon. Same drug, faster drip. Same treadmill, different reward, same shrinking door. None of this is a flaw in your character. It's not proof you're impossible to satisfy. It's a forecasting system, running the same program it's always run. Keep you moving toward the next thing. Never let you rest on the last one. The letdown you feel right after winning isn't your brain malfunctioning. It's the mechanism completing its job description. Reward the reaching, not the having. But here's the actual twist, and it's a good one. That reward machinery was never rationed for the finish line. It was paying out in small doses every single day you were working toward it. You just weren't the one keeping score. Which means the good part was never trapped at the end. It was running the whole time, underneath the grind, underneath the waiting, underneath every small piece of progress you barely stopped to notice. The only real question left is whether you were paying attention while it was happening.